So unit circle and circular functions is what it's talking about. So basically being able to use your unit circle. So you may want to take your unit circle out so you can follow along and identify points on there. So up first is making sure that we understand that on the unit circle, your x coordinate is your cosine, which we learned already, right? And our y coordinate is our sine, which we've already learned also, correct? Agreed? Okay. Next is that we've reviewed arc length, how we reviewed how to find arc length of a circle. Yes, we reviewed that. And lastly, we've talked about your unit circle is called a unit circle because the radius is 1. Does that make sense? No. Okay. So that's why we call it a unit circle. All the trig values on here, you can use your x and y to find all trig functions, remembering the ratios between our sine, cosine, and tangent. So really quick, do you remember these rules? That sine of an angle is y, cosine of an angle is x, tan is y over x, x cannot equal 0. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tan. All we've learned this, right? So at this point, we need to be comfortable using this unit circle that we now have fully filled in, correct? Our unit circles are completely filled in to answer questions pertaining to the unit circle. Okay. So for example, also noting it's going to always be symmetrical with the x and y axis in the origin. Because of the symmetry, if you know quadrant 1, you know the rest of the circle. So if you know what the ordered pair is in quadrant 1, then that means you know the rest of the ordered pairs because it's just a change in the signs. Does that make sense? So if I'm at cosine of 30, all angles with a reference of 30 will have the same numbers, but change in signs. Make sense? Reference of 40 at 45. And it keeps going. Okay. So your reference arcs are what helps you. So for example, like I said, if I'm at pi over 3, which is 60, and I know that the ordered pair is 1/2 negative square root of 3 over 2 on the unit circle, then I know that the rest of it and all the other quadrants are going to be just a change in the sign based on the quadrant it's in, right? All right. So again, it's just building on. Building into our first identity is that since it's a circle, x squared plus y squared equals 1. That means that cosine squared plus sine squared also equals 1. So if I know cosine, I can also find the sine of any angle. If I know sine, I can also find the cosine of any angle using this rule called the Pythagorean identity. So this would be our newest information. Everything else should have been reviewed. Okay. So Pythagorean identity is cosine squared s plus sine squared s equals 1. This is useful when you know the cosine of an angle, but you need to find the sine. That's because you would plug it in, square it, subtract it from 1, take the square root, use your math skills. Okay, do we all write down the Pythagorean identity? Huh? Because we've written down x squared plus y squared equals 1. Now we're correlating it to sine and cosine. All right. Okay. So sine and cosine are functions. They're functions with the domain of negative infinity to positive infinity. And then we're going to talk about tangent and secant. Tangent and secant are also functions. The domain is s cannot equal. There's asymptotes. So they have vertical asymptotes at these points. So this means that there are vertical asymptotes. Okay, n just means n can equal 1, 2, 3, whatever n equals. It's just a pattern of asymptotes. No, I got it. You got it. Okay, and then here cotangent and cosecant also have asymptotes, and their asymptotes are at vertical asymptote. And n is an integer. We'll dive deeper into the functions and what they look like. It's got really hot. Okay, so these again are the domains of our sine, cosine, and tangent. You're good. All right. Thank you. All right. So how does this work? If I ask you to find the sine of 3 pi over 2, the cosine of 3 pi over 2, and the tan of 3 pi over 2 using your unit circle, is that something you feel confident being able to do? Exactly. So what is 3 pi over 2? There we go. It's at 0, -1. Yeah, I said, shoot, I was agreeing with both of y'all. I said, we're right here. I was just saying, yeah, 0 and negative. There you go. So, my bad. I wasn't trying to. So we have the sine of 3 pi over 2 equals the y value there, and that is -1. What is the cosine of 3 pi over 2? 0. And your tan at 3 pi over 2? It's going to be what? Undefined. Why is it undefined? 0 can't be in the denominator because you have -1 over 0, so therefore it's undefined. It's y over x. Tangent is y over x. Okay? Do we feel confident in using the unit circle to do that? Yes. Okay. Oh, are you ready? All right. So, now what if I have a value, like cosine of 7 pi over 4? Could you still do it? What about cosine of 7 pi over 4? Square root of 2 over 2. What about sine of 7 pi over 4? There we go. So cosine is square root of 2 over 2. Sine should have been negative square root of 2 over 2. Agreed? All right. Now, what happens when I have an angle that is smaller than 0? Dun, 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 dun. So you can find it and flip it. You can add 2 pi because it's in radians, right? If I add 2 pi, it'll take me to where I'm going to go. But you just got to be mindful that it's going the opposite way. Does that make sense? So I like to just find 5 pi over 3 and then reflect it. So if this is positive 5 pi over 3, then negative pi over 3 is going to be this guy. Does that make sense? Right here? Oh, you're reflecting over x, not y. You're reflecting over the x, not the y. Okay? Because it's saying instead of rotating like this, boop, you're now rotating like this. Boop, 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 boop. Does that make sense? So if this is positive 5 pi over 3, you're going to reflect to find your negative 5 pi over 3. So this is my negative 5 pi over 3. Does that make sense? And your tangent again is going to be y over x. So you have the square root of 3 over 2. I'm going to multiply by the reciprocal because when you divide by a fraction, you multiply by the reciprocal. And that's just going to leave you with the square root of 3. Keep, change, flip. I don't know why I did 2 pi over 3 again. Oh, I did 3 pi over 2 the first time. My bad. Okay. All right, really quick. Make sure we're good. What's cosine of 2 pi over 3? -1/2, -1 over 2. Easy peasy. Okay.
Wait, can you explain B?
B?
Yeah.
Okay, so negative 5 pi over 3 means that instead of rotating counterclockwise like we normally would for a positive 5 pi over 3, you now are going to rotate clockwise. Does that make sense? And that's why you end up here. So essentially all you're doing is reflecting over the x-axis. So we're using the values of 60 instead of the values of positive 5 pi over 3. Okay, if that doesn't work for you, think about it in this sense. If I'm at negative 300 and I add 360, where am I at now? 60. Does that help?
Oh, yeah.
Because of your coterminal? Yeah. Yeah. Because of coterminal. Oh my gosh, I'm sweating. All right. This is just calculator. Okay. With calculator, you need to just make sure your calculator is in radian mode. Make sure you are in radian, not degree. How do I know it's not a degree? Because there's no degree symbol. Okay. So you just want to make sure you're in radian mode and you just type it in. There's really not else to it. Describe calculator. Any questions about calculator? We're good? All right. So we use this when things are not on the unit circle. Does that make sense? So this is your option to use when it's not on the unit circle. So these radian values are on the unit circle. So I'm just going to plug them in the calculator. However, remember when you have your reciprocals, you have to put 1 over that because it's the reciprocal, remember? So if I'm looking for cotangent, it's the reciprocal of tangent. So it's 1 over tan. Cotangent.
Oh, I put that in the.
So you would put, so you don't just put, there's no cotangent. So you have to put 1 over tan. You have to put 1 over tan 1.329. Because it's the reciprocal of tangent. Does that make sense? So for secant, I'm going to put what? 1 over cosine. So I'm going to put 1 over cosine and then put the value in. Okay. So for your cotangent, secant, and cosecant, you have to put 1 over their reciprocal. Still good with the calculator? Just making sure.
Yeah.
Okay. Do y'all need me to model it or is my picture good enough?
The picture's good.
Okay. I felt like it was safe. Okay. Whew. All right. Making sure you are in degree mode when you're given degrees and making sure you're in radians when given radians. I know it can be annoying, but that's a big difference in your answer being right or wrong. Anytime you reset your calculator, it automatically is in radian mode. So anytime you do second plus 712, it's going to automatically be in radian mode. Okay, so keep that in mind.
Wait, what do I do? Is doctor's name?
It's at the top. Okay, all right. So, how do you find the angle? Well, it's called the inverse. So you're going to press second cosine to find the inverse cosine. So in our calculator, we're pressing second cosine, and then we're typing in the ratio that we're given. So it gives us 9,685 10,000ths, and it wants to know what is the angle. And that is your angle measurement in radians. That's it. I haven't did anything. Oh, I apologize.
So you find inverse, you do the second sine, cosine,
And then you're using their inverses. So cosine -1. So you hit second cosine, second sine, second tangent on your calculator. It'll give you your inverses.
and this
Angle. So you're giving your ratio. So it says this is your ratio value. And now you want to find the inverse. So to find the inverse, to get this little guy, you're pressing second and whatever the trig ratio, the trig function is.
And that's what you find the angle.
That's to find the angle. Because notice here it just says cosine S. We don't know what it is. So let's approximate the value of S. Yeah. All right. So so when we put it in, we get 0.2517, and 0.2517 does fall between 0 and pi over 2. Okay. Wait, pi is what? What's pi? 3.14, right? What's half of 3.14? I'm like, what is it? Half of 3.14 is roughly, anyone want to take a stab at it? 1.57. And is that number less than 1.57? Yes, it's between 0 and 1.57. Okay. All right. Now we're going to do it a little different. It says that it wants us to be between pi and 3 pi over 2. So sometimes you need to see this in terms of degrees. So basically, it wants you to be between 180 and 270. Does that make sense? All right. So what's going to happen here is that the calculator is only going to tell you angles that are less than 90 degrees. Pi is 180. 3 pi over 2 is 270. Correct? Yeah. So we're in quadrant 3. Between 180 and 270?
Is it 460? Oh, yeah.
So we're in quadrant 3? Oh, okay. Just making sure. All right. So we're going to do tan of S equals 1. Again, I'm looking for the angle. So I'm going to have to use what? The inverse. I'm going to have to use the inverse. If I'm looking for it, I'm going to be using the inverse. Okay. So you can think about this at tan of pi over 4. If you want to think about your unit circle, that equals 1. Why does it equal 1? If you look at tan of pi over 4, what's pi over 4? On your unit circle. 45s, right? And for your 45s, your x and your y are the same. So their tangent value is 1. Does that make sense? So this is like, oh, okay, I have an idea. Without using my calculator, I can determine that this is pi over 4. But pi over 4 is in what quadrant? 1, and I need to be in what quadrant? 3. So I'm asking for a 45-degree angle or a pi over 4 angle that's in quadrant 3. What is my 45-degree angle in quadrant 3? 225, which is equals what in radians? 5 pi over 4. Okay, so you go through all of that, figure it out. Now we're going to talk about this is using the unit circle. This is using the calculator. And I'm going to model it better in the calculator for you. So let's go to my handy dandy Sylvie. Sylvie, open up.
So do you have to do this math?
So there's going to be certain values that I give you that you should only need the unit circle for. So on this test, you have a calculator part and a non-calculator part. So we got to be comfortable using the unit circle. So this is an example where your unit circle could have been utilized. Does that make sense? If it's on the calculator part, you also can use the calculator. Okay. No. You'll be given a blank one before the test starts.
But that's counted as a grade 2, right?
It's part of your test grade. Yeah. On the non-calculator part,
I don't think they're quiz.
you have a blank quiz on Tuesday, but on your test, there is another unit circle. Yes.
Wait a minute. Okay, I'm fine.
Sorry to be the bearer of bad news. Okay. All right. If you are not comfortable working in radians, you can 100% do this in degree mode. You go to mode, you're going to go to radian and switch it to degrees. If you want to work in degrees and then switch back, guess what? I won't be mad at you. I don't know what you're doing. So if you choose to do that, I'm going to now be in degree mode. So when I hit second tan inverse of 1, guess what it's going to tell me? Anyone? Anyone? What's it going to tell me? No. What angle did we say? It's going to say 45. Okay? So it's saying that any angle with a 45-degree reference is going to be a tangent of 1. Does that make sense? Yes? So if I need to be in quadrant 3, that means at 180, I need to be adding 45. So 180
Next.
inverse second tan.
One.
Uh-huh.
Yes. Like, I'll put it in degrees.
Yeah, I was showing you that what it would look like and thought it would be less stress, and
Honestly, I think I like that. Radians
That's
give
why-
you a whole bunch of numbers.
that's why I'm showing you
And
the
we
other
can
option.
use it in
And you just got, if the answer needs radians, you just got to convert it in. Does that make sense? My watch? Yes, I did. I cleaned my office room in there. There you go. All right, so 225. That's my angle in the third quadrant, right? Well, it wants it in radians. How do I convert a degree to a radian? Pi over 180, but I'm not going to put pi in the calculator. So I'm doing 225 divided by 180, or I just know what it is, but and I want it as a fraction. So it says 5/4. So 5 pi over 4 is my radian value. Does that make sense? So if radians are intimidating you, you have the choice to work in degree mode and convert in the in. Got it?
They ask you like sine, you
Huh?
put sine inverse 1, and then that's the number you use, and then plus the 180.
So like, that's it, by the way. So like on the cosine inverse here, right? So you have the cosine inverse of this. I'm in degree mode, correct? I'm gonna use second cosine, 0.9685. And it says this is your degree. So my degree is roughly 14 point whatever, right? But I need to convert it to radians because the answer is in radians. Since this is all in degrees, I'm going to multiply this by, pi over 180, right? But I am using pi because it's a decimal. It's not an exact value.
So probably this.
If there is not an exact value, you're using pi. So I'm doing pi divided by 180. Hit enter. And do I still get the same result? Yes. So degrees is where you're more comfortable at, and that's what you would do.
Degrees is actually. So, radians give you 2 meters.
Okay. It's up to you. No pressure. This is it for our lesson.
Really?
Yeah.
So would that be on the calculator part?
This would have to be a calculator part. There's no way you can use your unit circle to solve that. But like if I said the tan of an angle equals square root of 3, you can use your unit circle to figure out which one gives me square root of 3.
We're doing 2.4?
No, not today. Monday. We're doing it on Monday.